Okay, welcome to this first video for our Grade 8 Term 1 content, guys. This first one's going to be operations on integers. Okay, now you'll have seen us talking about in class this idea of a learning goal. Okay, and so that's something you need to really sort of think about, get in your mind, and sort of start to think about what it means. Okay, now again, the learning goal for this unit is, or at least this part of the unit, is that students use efficient mental and written strategies to carry out for operations with integers. Okay, and by the end of this video you will want to be able to understand the associative and commutative laws and correctly apply the addition, subtraction, multiplication and division algorithms to integers. Okay, right, so the inside info on integers. Let's have a look at this. Now, integers are all this, let's define this properly. We're going to have them as the set of positive and negative whole numbers including 0. Okay, now there's a special letter for the integers, and it'd be great if we could use it. Okay, so that is a capital Z. Okay, so this means integers. The integer set. Okay, and if it was something like Z plus, that would be our positive integers. Okay, etc. All right. Now let's have a look at some of these key ideas. It's a fairly simple ideas to be communicated. A lot of grade 7 content here, really just sort of getting you up to scratch with where we're at. Okay, so firstly, the commutative law. So this might be a new idea for some of you. Commutative law, it holds for addition and multiplication. So commutative law is that thing that says that if we have A plus B, it's the same thing as B plus A. All right, so we can switch them around. That's what it means to commutate. All right. Now, same thing with multiplication. A times B is the same as B times A. Let's just see an example. 7 plus 3 is 10, and 3 plus 7 is also 10. 3 times 5 is 15, same as 5 times 3. So exciting, okay? But it's a really important concept. Alright, however, it doesn't work for subtraction and division. Okay, so 3 take 7 is negative 4, but 7 take 3 is 4. Okay, so it doesn't work for subtraction, nor does it work for division. I'm sure you can see that 8 divided by 2 is not the same as 2 divided by 8. It's massively different. Okay, so we can't do the commutative law for subtraction and division. Okay, right, another one for us to think about and be aware of is this idea of the associative law. Okay, and that means is that we have I'm going to generalize these sort of algebraically. It's a good idea for you to see these rules and laws as a little bit abstract, not sort of tied down to particular numbers. Okay, it's just ideas and patterns that are within the set of integers. Okay, so the associative law is that if we have some numbers A plus B plus C, we can either, if we added A and B together first before adding C, that would be the same as if I had A plus B plus C. So if I added these two together first, before I added A. Now it's a bit tricky. Let's see an example. If I had 1 plus 2 plus 3, right? If I add the 1 and 2 first, I will get 3 plus 3, which is 6. But if I did 1 plus 2 plus 3, 2 plus 3 is 5, so 1 plus 5 is unsurprisingly 6. Okay, so that works for multiplication as well. Okay, what the associative law means, you can just do it in any order. Okay, right, but subtraction and division does not hold for the associative law. So that means, for instance, if it was 7 take 3 take 5, that is not the same as 7 take 3 take 5. Those two would not equal the same number. Okay, so you wouldn't be able to carry it out like that, so you just need to be careful. Alright, same with division. You can't switch the order with division when it's around. Okay, it's helped a lot when we move away from the division symbol and move to fractions instead. Okay, right, let's just take a super quick look at some of these algorithms that you have probably seen before, but just going to sort of fly through them. Remember our addition algorithm, so if I had 452 plus 96, okay, we add down the column. 2 plus 6 might have different colours. 2 plus 6 is 8. 5 plus 9 is 14. Carry the 1. 1 plus 4 is 5. Okay, so you're probably super duper familiar with that. Alright, we can also have a look at the subtraction algorithm, which is very similar. If I had 293 minus 77, okay, remember there's that idea now that because 3 takes 7 is going to get us a negative number, we kind of borrow from here. We cancel. We turn that into an 8, bring 13 here. 13 takes 7 is, wow, 6. 8 takes 7 is 1. 2 takes 0 is 2. So 216. Okay? Right. You also need to be somewhat familiar with the multiplication algorithm. So if it was 291 times 15, okay, we would rewrite that as 291 times 15, like that. Line it all up. Let's bring out a different colour. So we multiply from this one first. 5 times 1 is 5. 5 times 9 is 45. Remember, this 4 up here doesn't make it 42. 5 times 2 is 10. Plus another 4 is 14. Okay, now, so I'm going to move, I've done with the 5, so that's done. Now I'm going to move over to the 1 here. So now I'm going to put a 0 because I'm now multiplying by 10. Okay, so 1 times 1 is 1, 1 times 9 is 9, 1 times 2 is 2. So now once I've got those two numbers, I simply add them together. And I have 5 plus 0 is 5, 5 plus 1 is 6, 9 plus 4 is 13, 1 plus 1 plus 2 is 4. 4,365. Okay. Now, lastly, something for you to look at is the division algorithm. Okay, so you get plenty of time to practice this in class if you're not feeling like you're sort of understanding what's going on. Okay, so where's my little cursor? There it is. All right, if I had maybe 463 divided by, I don't know, 4. Okay, we would rewrite that in our division algorithm. Okay, 4 out here, the dividend goes in the middle here, 463, and the quotient goes on top. 4 into 4 goes once, 4 into 6 goes once with 2 remainder, 4 into 23 goes 5 times, remainder 3. Now you should be moving, starting to think of, oh, I'll put remainder 3, we're moving to decimals later. So there we go, remainder 3, okay? Right, that's your different algorithms. You've got plenty of time to chance to practice that in the examples and the textbook and your hot math stuff. So have a watch. Maybe you want to get started on that, and I'll see you in class. Thanks.